solving rational equations. All right, so so far we've just simplified rational expressions, right? We called it different things. We talked about adding rational expressions and multiplying rational expressions, but everything that we did was simplifying, and they were expressions. What's the difference between an expression and an equation? What's an equation have?
An equation has an equal sign.
It has an equal sign. Right, exactly. So we're going to start today looking at equations, right, where both sides of the equation typically are rational expressions. Okay, so we look at something like maybe like this: 5 over x squared plus x plus 1 over x squared equals 7. This is a pretty simple example. And these actually are easier than what we've been doing.
Wait, are we solving
Because,
for x?
yeah, so we're going to solve for x. But the whole point of rational equations is that we're going to clear our denominators. It's really similar to something that we did last year, which was if I had like x over 3 plus 5 over 3 equals 7 over 3, we multiply everything times 3, right? It's just that here our denominators are often a little bit more complicated. So here our denominator is x squared. So I'm going to multiply everything times that denominator. And that's going to cancel. Now remember, you're going to multiply every single fraction, right? Each term gets multiplied by x squared. So then that just becomes 5 plus x plus 1 equals 7.
So x 6 equals 1. So that's 6 plus...
Right, so 6, I could subtract off the 6. X would equal 1. Now there's one other step that you have to do, which is you have to go back to that idea of excluded value. You have to think about excluded value. Would x equals 1 be an excluded value in this original problem? No, right? Because the denominator doesn't say x minus 1. So we do have to check to make sure that it's not. And if it is, then we don't count that as an answer. But in this case, the only excluded value is 0, and we're not saying that x is 0. So we're okay. X equals 1 is our final answer. So the idea here is to try to simplify these problems, right? You're not trying to add the rational expressions together. You're not multiplying rational expressions. You're not subtracting things over. You're just simply trying to clear out your denominator first. So if I had something like this, how about m plus 7 over 2m plus 5 over m equals 19 over. If I have something like this, this is very similar to, again, I'm going to go back to something we did last year. If I had like x over 6 plus 1/3 equals 7/3. You have to multiply by the largest denominator, right? So like here I would have multiplied times 6 to clear out all my denominators. And when I multiply this times 6, it became 2, right?
You get 3 or 2 on that.
Right, so I would have been left with that 2. So in this case, I'm multiplying by the least common denominator, which is 2m. But when I multiply everything times 2m, this one just cancels. But what happens here?
The bottom
The
one
m's
cancels and you get
cancel.
one
I
M.
still have 5
get five
times
M.
2, right? That 2 sticks around. And when I multiply this times 2m, the m's cancel. I still have the 19 times 2. So then I end up, though, still with a fairly simple problem. When I multiply my 2's, right? So I've got m plus 17 equals 38. Subtract the 17. M equals 21. Alright? But you can start to see how these could soon become more complicated problems. So far, when we just have m, we call these linear, right? So far, these have been linear. We haven't had any m squareds or anything like that. But it is definitely possible to get something that's like a quadratic that we have to solve, right? Or something that involves a few more steps to solve. So I'm actually going to do one from your homework now. This is, so on your homework, actually I should probably just say this first. On your homework, you're only going to do 1 through 10. You're not going to do the back side of this tonight. We're going to do the back side tomorrow. Okay. So this one on your homework is number 4. I'm trying to memorize it, but I 4 over n squared is 5 over n minus 1 over n. All right. So what do we have to multiply by to clear off all the denominators? N squared, right? Because n squared here will cancel. N squared here will cancel. Don't forget we also need to multiply this fraction times n squared. And what happens here is that the n cancels, but there's one n left up top. Right? So this one just totally canceled out, so that's 4. This one I had an n left, so I've got 5 times n. And over here I have minus 1. So I had kind of like an n left over in a way, right? But this is still a linear equation. So it's still not a quadratic. It's just now a 2-step equation. So I'm going to add 1 to both sides. Oops. 5 equals 5n, so n would equal 1. Now I forgot to do something in the last problem, which was what? I didn't check to see if that answer was an excluded value. Is 1 an excluded value in this problem? No. Right? That's called, what it's called when you're solving is, they're not necessarily called excluded values. They're called extraneous solutions. Right? So an extraneous solution is a solution that doesn't work because it was an excluded value. It was something that canceled off in one of the first steps, right? An extraneous solution is like, it would have been a solution if you had started here, but it's not a solution since we actually started up here. Right? All right. So do you guys agree with me? These are kind of easier than what we've been doing, right? Mm-hmm. You're not, I mean, they look more complicated because it looks like, oh, I've got to subtract these and then I've got this other one on the other side. But if you just remember that key step of figuring out how to clear your denominator, they become way easier. So I just want to look at that, just that step. We're not going to do the following problems. I just want to look at what would you multiply by in order to clear these denominators. Okay, so what if I had this? And the numerators don't really matter. Alright, what would I have to multiply by in order to clear all of those denominators? Okay, so I just heard the answer if we combine what you two just said. 4 is going to clear both the 4 and the 2.
4x to the
So
third.
I'm going to multiply times 4. X to the third is going to clear both the x squared and the x to the third. So I would have to multiply everything times 4x to the third. Even though that's not one of my denominators. None of the denominators are 4x to the third. But this is the smallest denominator that will clear this, this, and this. Right? I can't do a smaller number because it wouldn't clear this 4. I can't do a smaller x because it won't clear this x to the third. So I multiply everything times 4x to the third. We're not going to actually solve this. We're just going to look at what would happen. Here, the 4's would cancel, and the x squared would cancel 2 of these. So I would just have x times x. Here, the x to the thirds would cancel, so I would just have 1 times 4. And then over here, the 2 would cancel with the 4, so I would have 7x times 2x to the third. And I would end up with x squared plus 4 equals 7x to the 4th. Which is not something that you guys know how to solve.
Wait, 7? Wouldn't it be 14x to the third? Because
Oh yeah,
2?
sorry, you're right.
Wait.
14x to the 4th.
Yeah. Oh yeah, 4. So
Because you have 1 here.
that's not gonna be on our.
So yeah, this particular example wouldn't be on your homework, but I just want to look only at how do we clear these kind of different denominators. So what if I had something like this? 1 over 3x squared plus 1 over 5x equals 1 over 10x.
We'd have to do it by 10x squared.
Okay, so the x squared would cancel all my x's because I don't have anything bigger than x squared. But the 10 would only cancel this and this.
15x squared.
The 15 would cancel this and this. So 30, right? It would have to be 30 because 30 is the smallest number that cancels 3, 5, and 10. It's the smallest common multiple, right? The least common multiple between 3, 5, and 10. Yeah. So 30x squared would be our multiplier here, right? And I'd multiply everything times that. Here, it would cancel, leaving me just 10. If I canceled this, right? 30x squared times this. 1x would cancel, and the 30 would become 6. So I'd have 6x, right? And then over here, that 1x would cancel, and then I'd have 30 canceling with 10 would be 3. So I'd have 3x. So this is often the hardest step, is this very first step of figuring out what to multiply by and then making sure you're properly canceling each term. Now, for the homework tonight, the side that you're going to do, 1 through 10, the first 10 problems, all of your denominators are going to look something like this. They're going to be one term. You're not going to have any denominators that are 2 terms. So you won't see any denominators that are like x plus 1. Right? But that's going to be our next step, is to add in slightly more complicated denominators. So just stick to the front, because if you go on the back, you'll start to see some of those with the, polynomial denominators, binomial denominators. Okay, any questions about how to do this? All right.